All right, question 4 here, natural log to the 9th power of x over x. And so we're going to have to solve this integral by use substitution. And when you make a use substitution on this guy, it's going to be just a little bit on the different side because you're trying to look in here and what is the different derivative of the other, okay? What's going on is we've got a natural log function to the 9th power and we've got 1 over x. And as it turns out, if we let u equal natural log of x, then du is equal to 1 over x. And like we did on the first slide, we would just add that dx to the side. So when we substitute what we know here into this problem, I'm going to end up with u to the 9th, because that's the natural log, u to the 9th, not second, u to the 9th, over x times dx. Well, remember, this is 1 over x times dx, and that's the same thing as du. So I'm actually integrating u to the 9th du. And when I do that, I simply add 1 to the exponent and divide by the new exponent. U to the 10th over 10 plus c. And when you substitute in what our u is, that's the natural log. So natural log to the 10th power of x over 10 plus c, that's your final answer right there. On 5 is also a substitution situation, and we have to look at this and go, okay, I've got something to the 6th power, something squared. Which one of these is the derivative of the other? And if you look at your trig sheet, or if you look at a derivative sheet or whatever, we'll see that the derivative of the cotangent is cosecant squared. So we'll let u equal cotangent x. Du would be negative cosecant squared x dx. And again, because we multiply both sides by the dx, go ahead and write what we've got so we can just have a little look. So u to the 6th, remember cotangent, u to the 6th times the cosecant squared of 6x dx. And that means that this needs to be a 6 here and a 6 here. I forgot to write those in. They're right there. All right. 6x dx. And look, I've got 6. Let me do a different color. I've got a 6. I've got an x. And I've got a dx. Okay? So this is looking good. This is looking good. By the way, this should be... I have messed up this derivative. Let me just write it cleanly. So this is going to be negative 6 cotangent 6x dx. Sheesh. Negative 6 cosecant squared. Six x dx. Okay. So all we have to really lose is that negative sign. And that would give me negative du equals 6 cosecant squared 6x dx. Now we're off and running here. And this guy is equal to this guy right here. So again, the only other thing that I would need to move now to get my equality is this 6. So he would go to the other side as well, which gives me that shape right there. And now he's gone. And now I'm ready to rock and roll. Okay? So what am I going to integrate? I'm going to integrate negative 1/6 u to the 6th times du. We're going to add 1 to the exponent, divide by the new exponent. And so negative 1/6 times u to the 7th over 7 plus c. And when I substitute my u's back in, this is going to be negative 1 over 42 times the cotangent to the 7th power of 6x plus c. And that's that guy right there.